do you like Adam Murray or Adam Patrick Murray or Adam from PCWorld?
Adam Patrick Murray.
I
got a funny story about that. So, well, it's not that funny. It's just SEO, really.
Yeah, I get that. It's when you have two common names stuck together, it turns out it's hard for people to find you. Who knew?
Yeah, when I first went to go make my website, there was at least 3 other famous Adam Murrays. Like there was a soccer player or football, whatever. There was a politician. And there was somebody else. So I was like, all right, you know what? I'm just going to start going by Adam Patrick Murray. Let me Google it. And at the time, there was like just no hits. Now there is one other Adam Patrick Murray that you can find, and it's a Florida man.
Oh, no.
It's a new story about a Florida man. So,
oh, no.
That's not me.
That's the whole thing where like criminals and I hate to say this, like serial killers, they always use like a middle name to try to differentiate from other people. That's not.
Yeah, you know, I've been told that as well. Like, hey, you know, you realize you're setting yourself up for failure on that one. I'm like, well. Maybe I'm hiding in plain sight. You just don't know.
There's another Adam Patrick Murray out there who's a ticking time bomb, just waiting to destroy your reputation.
But you should just switch to a symbol. I was thinking about switching to a symbol. You know, it worked for Prince. You know, I'll design something.
Hang on, let me use one of our recent tips from a past episode and hit window period and pull up. Okay, got the emoji picker. What's your?
I feel mad this morning, if I'm being honest.
Do you want to be
emoji picker?
Do you not use the emoji picker?
No.
Windows plus period. Oh, we're about to blow your mind.
Hey, there it is. Oh, wow. Oh, I like the Ninja Cat. It was the first one that popped up that I was like, yeah, I dig that one.
That sounds good. All right. Old Ninja Cat Smith.
Smiling face with sunglasses.
Brad and Ninja Cat made a tech pod.
Yeah, Brad and Ninja Cat made a tech pod. I want to be Merman. I want to be Merman with no shirt, though.
Sorry, Merman is taken. Ask me how I know. Could I interest you in a piece of fruit or here we go. How about a potato? What do you think, Will? I mean, potato.
Welcome to Brad and Will Made a Tech Pod. I'm Will.
I'm Brad.
Hello, Brad.
Hi. Your browser window was like 3 windows deep. I didn't actually see you talking.
Oh, it's okay.
Caught me by surprise. It was like Invisible Will.
Well, I mean, sometimes I'm here, sometimes I'm just in your brain.
Mm-hmm.
This is the beautiful thing about having, when I walk around with my AirPods in all day, I just occasionally like something will start playing or I'll have like chill music going and then I'll get a call. It's like, phone's ringing. This is terrifying. I haven't heard the sound in years.
Oh, right. I have machines in my ears and they do that sometimes.
Yes. Brad, today I'm really excited. We have, as you guessed from the cold open, we have a guest on the show. Our friend Adam Patrick Murray from PCWorld is on. Folks who are longtime listeners may remember earlier this year and late last year, you and I both went over to PCWorld where we built PCs with Adam and Gordon. Over there. They kind of guided us through the process of the modern 13th gen / Intel / 5th gen AMD. Is it 5th gen or 4th gen?
Oh my God. It's Zen 4 on AM5, which is
fifth gen socket, 4th gen Zen,
something
like. Look, it's complicated, but Adam is often we have Gordon on during this time. Gordon's out right now, so this week Adam's on the show to talk to us about the stuff that Intel rolled out at their innovation event earlier this week, including new CPUs, next year's CPUs, and then getting further into the weeds a little bit with things like neural processing and longer term plans from the big blue chip maker.
Foveros and Angstrom, and there's a lot of other terminology in there.
Look, you take your Angstrom and shove it, Brad. Welcome to the show, Adam. We're so glad to have you here.
Oh man, I got to tell you, I'm honored to be here. I followed both of you guys' work for a long time, and yeah, the fact that you wanted me on the show, I'm just like, what? Me? Who? What is it? Oh, yeah. I'm excited to be here.
Thank you for coming on. You're the keeper of the forbidden knowledge. You know about tiles and Foveros and whatever they're calling the CPUs now. So hey,
we're getting chiplet crazy up in here.
The information, I just happen to stand in front of the information and it hits me, you know, and some of it sinks in, some of it just like goes past. So that's how it goes.
But yeah, you covered Intel Innovation, which is I think this is like they're developed. They don't have a developer conference really, but it's like hey, here's what we have coming soon and later, and they do it every year. It seems like they didn't used to call it Intel Innovation. They just call it a press event in the old days. Now it has a name.
Well, actually, the thing that Gordon likes to point to, which I had never been to, my coworker Gordon Ma-ung.
You may remember him from such publications as Maximum PC and PCWorld.
And Brad's PC build video.
There you go. Yeah. He likes to kind of link it to IDF, the Intel Developer Forum. Like in a lot of ways, he's like, oh, you know what, Pat, that was Pat's thing. And then IDF kind of trickled away when Pat was gone. And now that Pat's back, he's like, yeah, let's make this, let's have a developer forum. So, I mean, they talk a little bit about hardware. I mean, we definitely got our hands on the first Meteor Lake laptops, but at the same time, it was all about getting developers, that kind of stuff. So
yeah, it's funny because the GPU people have done this for a long time. Like NVIDIA does their developer conference, AMD does developer reach out days. The NVIDIA's what used to be their developer conference has become that NVIDIA, like it's all about graphical compute and machine learning and stuff now. It's kind of crazy. And it's usually when they roll out new hardware. So it felt weird when Intel kind of moved away from this, and I like that it's back.
Yeah, like I said, Gordon kind of equates it to Pat. Like it was probably a Pat kind of thing. So I think that makes sense. But I should point out, Gordon is on. Was not able to join us at Intel Innovation, unfortunately. So I was kind of there in his stead. Usually, for people who know us on the PCWorld side, I'm the video guy behind Gordon. So I feel lucky to be able to hang out with him and learn from him. And usually I have the stupid questions, and he's like, oh, okay, well, this is what that means. This time I had to kind of be the face of PCWorld, so kind of a newer thing for me.
So it's a long tradition of small, scrappy media outlets that the video and production people just find themselves in the spotlight eventually.
Yeah. Oh, I mean, sorry, we're not even getting into innovation, but yeah, like it's been a crazy history here at Foundry is the company that employs me technically, and so I'm on the video team, but I run the main B2C channels. So, and PCWorld is our main one that we focus on. So it's been fun. 2017 was kind of when I kind of took charge of the YouTube channels, and we can go into depth on YouTube, in the hardware ecosystem over there. But like I said, just hanging out with Gordon and learning from him, making the videos, doing the podcasts, like I've been able to kind of absorb a lot of knowledge, and I'm fairly new to PCs and hardware. I mean, I literally learned how to build from watching you, Will, and reading articles, and same thing with Gordon. So it's been a matter of me just kind of learning from the best and continuing there.
Well, I think you undersell yourself a little bit because you have a you pay. So back in the Maximum PC days when I worked with Gordon, like he focused on CPU stuff and I covered GPU stuff for a really long time. And then everybody else covered the other stuff because those were big beats that required a lot of time and there was a lot of testing and a lot of stuff. I think the thing that you have that frankly I never had, and Gordon has had off and on. I think it's stuff he kind of doesn't care about a lot of the time, but is like all the other stuff and what people are actually doing with stuff in the real world versus the actual benchmarks. Like you have, like you were the first person I talked to about undervolting stuff. You were the first person I talked to about reducing power consumption on high-end PCs. You were the first person I talked to about like what's going on with weird RGB controllers and how you can do open RGB now instead of having 25 different arbitrary pieces of software installed on your computer. And
well, don't worry, Windows is going to have it built in now.
Yeah. Well,
yeah.
Yeah. But fan control.
Fan control is awesome.
Fan control is amazing. The Windows building it in thing does not give me, I don't have a lot of, it doesn't give me a lot of comfort. But anyway, that's a different topic for another day.
Yeah. All this is to say, I was at Innovation with actually Mark Hochman from PCWorld. Like, so just to back it up a little bit. So Mark Hochman flew, I will say under the sponsored, Intel sponsored the travel to go over to Malaysia to see their fab over there. So he got the real deep dive, nitty gritty kind of stuff.
You have to go into the fab.
Yeah. Bunny suits, everything. it was nuts. So they offered us to go to Israel. It was late last year, maybe earlier this year. I can't remember. Unfortunately, we didn't go to that event. The Malaysia thing didn't work out for me to go either, but Mark was able to go, and they kind of showed off all their cool stuff. So, hopefully I get to go to a fab one day, because I think that'd be fun. But so he got all like the deep dive technical stuff, and then we took that knowledge going into innovation where they went to talk about it. So we had some pre-release stuff, and there's videos up over our YouTube channel. But this was kind of
PCWorld.com.
YouTube.com/PCWorld.
Okay.
But the idea is that, hey, you go to innovation, and I was kind of curious to see how they were going to message all this stuff, because I think that's the bigger thing that is exciting for me, is like there's a lot of technological stuff that's going on, but also the messaging is kind of the more interesting thing, because it is so complicated, and it's not just like, oh, hey, you know what? Now we got 4 cores. Hey, now we got 8 cores. Check this out.
Well, yeah, it used to be that you looked at it and you were like, oh, the CPU clock is 20% faster, therefore your benchmark's going to be like 19.5% faster.
Easy.
And it just doesn't work like that anymore. Like everything is complicated.
Especially coming off of the Skylake era, where it literally was just that for like 5 straight years or something. Of like, well, it's the same thing but 10% faster this year. I wanted to ask a real quick, like the highest level question we can ask about this event, which is you mentioned Pat a few times. That's Pat Gelsinger.
I'm sorry, Pat Gelsinger, CEO of Intel. So, like,
would you say this event is like the first major or the biggest showcase of the Gelsinger era? Because like it was kind of it seemed like kind of a big deal in the press when he came back as CEO, because like, there was this like Skylake stagnation period where they didn't have a lot going on, and then it was, the narrative has been like, oh, he's an engineer, like he knows where this company should actually be going, and like they debuted so much new forward looking stuff at this event. Like, yeah. I know that, CPU CPU roadmaps are like, steering aircraft carriers, they take years to kind of change the trajectory and get moving. So like he's been back for 2-3 years now as CEO. Is this like a taste of the future under his leadership?
I would say innovation last year. Like he came up there and was like, hey, we're really aggressive roadmap, 4 different nodes over 5 years, or I can't remember the exact thing he was talking about, but he made it very obvious that he wanted to move really fast and do a lot of things. Now, there's been a lot of talk of like, hey, they're not executing that well. They're getting, held up in certain process types and things like that. And they're, oh man, wow, they're having to work with TSMC. Now TSMC is going to make at least a couple of the tiles in Meteor Lake. Like, so I mean, like you can kind of interpret it different ways, but the way I take it is that I can tell that he's passionate and he wants to like really push things forward and is trying to be forward thinking. He's kind of a nerd, and like he doesn't have the best stage presence, especially compared to like Jensen, right, from NVIDIA. But like I just like that he's a nerd. He gets up there on stage. He's self-deprecating. He has fun with it. Like I kind of empathize a little bit more with him than somebody like a Jensen, who's just like so smart and so cool. Because I'm not. Well, and, so.
I mean, Jensen, just to be clear, Jensen has been practicing for 25 years now, and is like he didn't. They don't all start out. They usually don't start out like that. So it's interesting to see, because like 1300 series, 13,000 series, the 13th generation was kind of like, it's high and low, right? Because performance is pretty good, power consumption is really high, but it's not like it hasn't been. They kind of got stomped by AMD in a lot of ways. It's just they're a little bit on the back foot for Intel, and have been for quite a while at this point, it feels like, and it seems like they're finally making decisions that are going to, let them shift their direction a little bit more.
I mean, a lot of people want to kind of put down Alder Lake 12th gen, Raptor Lake 13th gen, and and say, hey, they're stagnant on the big power cores, and they had to kind of throw in these crappy E cores to make up for it in Cinebench numbers. But also, so I mean, okay, maybe to a certain degree, yes, but the philosophy of having 2 different kinds of performance to kind of lean on, and now with Meteor Lake 3 different kind of cores. And like, to me, I think it's more of like, hey, you know what? That was the first indication of things kind of need to change a little bit. And obviously on the AMD side, they've been working with chiplets and kind of trying some different things there, which is to great success, obviously. So I think it's more like, hey, sure, they're a little slow moving, but at least with Meteor Lake now, it's like, hey, we're diving in and things are going to get crazy in terms of like just performance. Like how do you understand engage performance back, Gordon, 10, 20 years ago would just run a Cinebench and be like, oh, okay, well, it's faster. Cool.
Yeah, how many IOPS does it make? Yeah.
Right. Yeah. So and that's where I'm excited to talk about is just like, I feel like this disaggregated architecture is like just nuts. And I mean, it has huge implications.
We should explain chiplets to people because I think it's it's not new on the AMD side, but it's still a relatively new concept to a lot of people. In the old days, you would buy a CPU and the entirety of the whole CPU would be cut out of a single wafer of silicon. It would be etched in like the traces would be carved by a certain wavelength of light, which made them a certain width. Yeah, and that's what we refer to as the process size often. Mm-hmm. So this chiplet thing is a different approach, right?
Yeah, so on the AMD side, chiplet. Here on the Intel side, they're calling it tiles, which, whatever.
Chiplet by any other name still is a chiplet, Adam.
Who knows? But yeah, the idea that you have separate things doing different kind of tasks, and then you kind of bring it together, like the whole, like you said, the whole idea of a north bridge, south bridge, that kind of stuff is going away as well, and it allows on the AMD side, right? They've been able to mix and match chiplets, or oh hey, you know what? We have a package with just one of the compute chiplets on it. So, and then Brad, your new PC, you've got two chiplets, and one of them doesn't have is just the normal standard cores. The other one has the 3D stacked L3 cache or whatever. And so it's just a matter of like, in the future, which I know we'll talk about naming a little bit later too, because like that's where things get real hairy. Is that Intel seems like, hey, you know what, with these disaggregated tiles, you're going to be able to mix and match. Hey, do you want 10 P cores, or do you want 2 P cores? Do you want a bigger graphics performance? Do you want a bigger NPU? The sky's the limit.
Just build your own CPU. I guess we should mention real quick, just for people who don't know, like the whole point of doing things this way is for manufacturing efficiency, because not every CPU that comes out of fab is good, right? Like that's what the process of binning is basically testing CPUs to see if they work right after they're fabbed. So when you're making the CPU package out of multiple chips from different fab processes, you can, you don't have to throw a whole CPU away because one part of it doesn't work right? Like you can mix and match the
yeah. I mean, it's that which obviously directly impacts cost. The less waste they have, the better yields they have, the less money they're throwing away. But then also it lets them iterate faster too. Like the other thing which kind of is talked about here is that for Meteor Lake, and it's going to launch on the laptop first. Intel did confirm Meteor Lake for desktop in 2024 to us, and the idea is that hey, the tiles can be upgraded in different ways. So like generational naming, what does that even mean anymore? Like if Meteor Lake was 14th gen, and then next year they're like, hey, you know what? Everything else is the same, but we replaced the tile for the SoC part of it, or we updated the graphics tile. Like, is that a whole new generation? No, not really. So like the way that the fact that they're getting away from generation naming is kind of a big deal in a lot of ways, for good and for bad.
So this isn't, I mean, my first question for me about Meteor Lake was, this isn't just because they're also reducing the process size for this. So generally when the process gets smaller, the cores can do more compute in the same amount. You can fit more transistors on the same amount of space, and that means that things get faster and they use less power per like the power per compute is less. Mm-hmm. It's not just a process shift. This is a whole new architecture kind of kicking off with the chiplet design, right?
Well, and each tile has its own process. That's what I'm saying. Like the fact that they can update maybe one process out of the whole chip, and just kind of reintroduce that into the market is kind of a different way of thinking of it too. Like it's once again, it's not a generational thing because maybe we'll get an update to one tile but not the other.
So does this feel like an answer? Oh, sorry, Brad.
Real quick, this is from the Verge story on this. Like I believe, so in this iteration of Meteor Lake, like for example, the graphics part of the chip is on TSMC's 5 nanometer process, but the IO and SoC tile are on TSMC's N6, whatever process that is, and then part of it is made by Intel. So like that's to your point, right? That like,
exactly
they can literally source parts of the CPU from other fabrication companies and just kind of slap it all together.
Exactly.
This is a response to the 10 nanometer process being kind of plagued by issues over the last few years, right?
Right. I mean, as much as people will give them grief, rightly so, it probably was one of those things where they were not happy with it, I'm sure, and they were like, okay, how the hell do we change this? How the hell do we get out, in front of this? And I think in the future, who knows, but I would think that this would allow them to be more lean and be like, hey, you know what, we can control each tile that's included here, and kind of have different ways of packaging it and upgrading it. But yeah, for Meteor Lake, there's 4 specific tiles. You have the compute tile, you have the SoC tile, which is very different, the IO tile, and then the
SoC
graphics
system
tile.
on a chip. In this case.
Yeah. And the reason why they call it that is because that SoC tile now has 2 low power E cores. So the compute tile has P cores and E cores, which, was introduced with Alder Lake. But now the SoC tile has, we're calling it shorthand LPE cores. So the idea, and this is more for the laptop side because that's mostly what they're talking about here, is that if you need to wake up the computer or you need to run something that's really low power, you don't need to light up that whole compute core. You can just light up the SoC core because it has 2 low power E cores, and especially that's where the media engine is as well. So you can play back video and just only use those 2 cores, and the compute tile is just sitting there dormant and not using power, which is definitely a huge advantage on the laptop side. How it works out on the desktop side is yet to be seen, but
yeah, that's interesting. It seems like they're taking that bottom up approach to task assignment, whereas like my impression of 12th and 13th gen, especially like looking at Linux kernel development and how they're handling it there, it seems like it was very much prioritize the P cores and have things trickle down to the E cores as necessary. And again, obviously, like the power needs are different on desktop versus laptop, but like to hear that they're it's this tiered, like, okay, are we going to just light up these like super low power ones? Like, do we have to even activate the compute tile? Like, okay, yes, we do. But now we've got the E-cores there. Like that seems really smart.
Yeah, we have a really good interview with Michelle Johnston Holthouse, who's the kind of the EVP and GM of the client computing group. She's awesome. She is great on camera. Good interview with that Mark did on our channel. Definitely go watch it. But that was one of the things that was kind of talked about was, hey, Thread Director has been updated to prioritize putting things on the low power E cores first, if it can, and then go that way, which makes sense on a laptop, but on a desktop, do I really want to throw everything to the low power E core first? They say, Intel says that actually can be tailored and changed depending on use case. Once again, we don't know. Meteor Lake on desktop isn't here yet, so that's something that I'm kind of curious about. But on the laptop side, I mean, that is definitely like a huge advantage to be able to use less power. I mean, that was kind of the other big takeaway is that all this is done for efficiency. They're saying the actual compute tile in there compared to 13th gen Raptor Lake is pretty much even. They're kind of already going out there and saying, hey, you know what, like set your expectations. Like the actual compute is not going to get a huge uplift, but it's all about efficiency. And lower power. The place that is going to get a big upgrade is the graphics tile, which is the first time they're going to have ARC graphics on the chip. It previously was XE, or however you want to say it.
Yeah,
I just say XE. But yeah, so the ARC performance, they're saying like 2 times performance on that, and then of course there's the NPU we haven't even gotten into. Which is the the AI stuff, quote unquote.
Yeah, it's interesting. So what's the block map look like for this? Does everything run through the IO ports and then everything spokes off of the IO, or is it the IO to SoC and then everything else out from the SoC port? Or did they get into that level of detail?
Yes, they did. SoC is the main driver, so it'll touch even the DRAM is plugged into the SoC, so everything kind of goes into the SoC and then gets disaggregated out from there, which is why they're especially for laptop stuff, they're like, hey, the more we can do on this SoC tile, the better, because it's the most power efficient, and it doesn't need for laptop. Okay, I should say for normal laptop users, right? The person just writing emails or taking it to Starbucks kind of thing, like that's what they want. That's where Apple has been able to kind of kill it, right? Is efficiency and whatnot. So like that they feel like in this new kind of SoC tile, that's where they're gonna have the big win.
Do they talk much about the interconnect between the tiles? Because that's the big downside for people who don't know between or the downside of this disaggregated architecture, which is how Intel is referring to this setup, is that if everything's on the same die, it talks to all the parts talk to each other extremely fast, and when they're not on the same die, you have to have some other way of facilitating communication between them. On AMD, it's called the Infinity Fabric. Do they talk much about what their version of that is, like how fast it is, like how much it's, because you run into things on AMD where it's like, the Infinity Fabric clock can only go so fast, and that's kind of affected by your memory speed as well, and like that can hold you back and bottleneck you in some ways. Like, did they talk about how theirs works and stacks up?
Yeah, so they typically they've run on a thing called a ring bus, so it's all on one chip. It has different stops, and then it's just easier to kind of put stuff around there. And they kind of famously made fun of AMD and just said, "Oh, it's glued together," quote unquote. So in this new architecture, it's mini rings. So essentially, each tile has kind of somewhat of a ring bus that talks to each other. There is a penalty to that, especially on the power. The engineering side of it is going way deeper than I can talk to, but like it is not, it is substantial, but it's not like not a huge thing. It seems like that it's something that they're touting to be not that big of a problem. But I mean, I guess we'll see. That's where the testing runs into, because if you have any sort of latency or penalty to fire up the big compute tile, especially for power users, I mean, that's going to be a problem. So
so you alluded to this earlier. They've said we've talked about North Bridges and South Bridges going away multiple times over the last decade and change, right? But it seems like this time it actually is for real happening because of the way the chiplets are architected. North Bridge and South Bridge, for people who don't know previously, and I always get this wrong, so please correct me when I mess it up. But in the old days, the South Bridge was the thing that like the slow stuff connected to. It was like SATA ports and maybe if you had ISA slots or PCI slots on a board with some PCI Express slots, you'd plug those into the South Bridge. Maybe your USB bus in the pre-USB 3.1, 3.2 days would plug in there, all that kind of stuff. And then North Bridge was the kind of memory CPU, video card, PCI Express slot, like the handful of places that you wanted to be real fast. These days it would be like your NVMe SSD, stuff like that. Did I do it? Did I hit
yeah. No,
okay.
That makes sense.
And so this is going away. This is all kind of getting sucked up into that those SoC and IO chiplets now, right?
Yes, yeah. So the IO tile specifically holds the things like PCIe. On Meteor Lake, it's Thunderbolt 4, which is kind of weird because they did just introduce Thunderbolt 5. So that's kind of, I'm a little bummed that this doesn't have Thunderbolt 5 support.
They always lag Thunderbolt a generation. Like they have they're always a year back on Thunderbolt and new chipsets, it seems like, though.
Yeah. And I mean, just to take a side tangent, like Thunderbolt is not a deal breaker for me. Like, there's been a lot of testing in USB 4 and things like that. And I feel like that's hopefully going to get to a good spot. But the one spot, which I'm just a weird pervert for, is eGPUs. And Thunderbolt 3 and Thunderbolt 4 hasn't been great for eGPUs. So supposedly Thunderbolt 5 is maybe where we're going to have another eGPU revolution. Oh, I don't know. I'm excited about that, but that's a separate thing.
So that's a weird thing to get into, Adam. I don't know. You're in a dark place, right? There.
Oh no! But the idea of having a thin and light laptop that you plug into an eGPU, like hell yeah, that's I mean, there's people who use it today and understand the downsides and still enjoy the benefit. But man, if you didn't have those massive downsides, like I could see a lot of people appreciating it more.
I think unfortunately it's always going to lag. But okay, so PCI Express, all of your main IO stuff is going to presumably plug into that IO chiplet memory, and then the IO interconnect, and then go into the SoC, and then the compute cores and the graphics cores and all the other stuff hook into the SoC. I am wildly curious to see how this benchmarks, because it took a while when AMD switched to the chiplet design for Windows to kind of know what to do with a variety of like the performance and efficiency cores, and how to handle the new like how to work with the bottlenecks that changed when this stuff changed. And I guess it's going to be I guess we'll see laptops sooner, but when we get to the big metal in the springtime, hopefully next year, or whenever they release Meteor Lake, we'll see more.
Well, yeah, and I mean that's the thing, right? And the secret sauce, at least according to Intel, is Thread Director, because that is something they had to work on for 12th gen and 13th gen, and kind of gives them a little bit of a leg up, is to say, hey, on our side, we can control where things need to go. We don't have to have Windows. I mean, it works in conjunction with Windows, obviously, but that is something AMD does not have. Is that layer in between. And there's a lot of people who don't like that idea of the Thread Director and want to be able to kind of control it themselves. But I mean, I think for the general purpose person, like it's going to be an advantage. And like I said, we're already thinking about these updates and how it's going to make sense here for the laptop side. Once again, the desktop side, that's a way bigger question. That for me, like I'm just like I don't know exactly how that's going to work out.
Do you guys actually manage what gets on a P core and what gets on an E core on your machines that use these processors?
Personally, no. There's plenty of people out there who, if they just game and they're on Intel systems, they'll turn off their E cores, and get a benefit. There's definitely people doing things like that. But for me, I like to use it and just experience it out of the box and see where it fails there. For Gordon, when he benchmarks the stuff, once again, he doesn't necessarily turn anything off. I mean, he does certain benchmarking that will say, okay, you know what, I'm going to stress the P cores and we'll see how the E cores add to it. But for the most part, I mean, general people don't do that, especially on laptops either.
Yeah, it's interesting because like I looked just to see what was running right now, and right now it's like the things running on eCores for me are the two browsers I have open and like a Power Toy that just is kind of always in the background and isn't particularly used that often. So it's just something I don't even think about, and I wondered if other people are thinking about that more.
Yeah, so AMD does not do eCores yet. They just have one core architecture across all chiplets. The thing I have, though, is what Adam mentioned earlier. I've got two chiplets, and one of them has way more cache for games. And does Windows know which chiplet to put a process on, if it's a game or not? Sometimes, not always, mostly. They've had to work with Microsoft, and I mean, it definitely gets better, right? Like, there was a lot of headache around Zen 1 launch. Like a lot of people were having problems with latency and things like that. And over time, I mean, it is just gotten better and better for sure.
So the addition of the AI coprocessor, they call them N cores, is that right?
NPU.
The NPU lives on the SoC tile.
And this is just like the normal, it's like the Tensor Core equivalent on NVIDIA GPUs. It's the thing that accelerates the kind of math that happens in machine learning applications.
Yeah, and we saw a nice little talk by Robert Halleck, which used to actually be at AMD for 12 years, and he jumped ship. Now he's on Team Blue. We also have an interview on our podcast, The Full Nerd, that you can go check out. But yeah, for them, it's kind of two things. It's like, hey, now we have a processing unit in here, and they say it's more similar to the GPU than the CPU in terms of computational stuff, which makes sense, but it's going to be better at certain things than each of them. Now, me being naive, I just assumed, hey, you know what? All the AI quote unquote stuff is just going to be best suited for the NPU. But in the various demos that they showed at Innovation, a lot of the people that were talking to us are like, hey, no, it really depends on the software, the implementation, what you're actually doing with it. And all the demos, usually you go to a trade show and they want to show like the latest and greatest thing, right? Not all the demos were actually using the NPU. So some of them were for sure, but a lot of them were using the disaggregated architecture of it and saying, hey, you know what, this one function is better suited over here. This one function is better suited over here. And the way they're kind of talking about it, at least on Intel side, is that this is truly a third pillar, a new third pillar in computing. They have the CPU, the GPU, now the NPU. And I mean, that's crazy. Like, when was the last time there was a new pillar?
A new
computing?
When was the last time there was we should say N stands for neural, just for people. Neural processing unit is what they're saying. It's funny how things worked out, because there was that massive Microsoft leak, the Xbox leak earlier this week, like the day before Innovation, I think. And
I can't remember the exact date.
On the Xbox slide about the next Xbox, the one that's going to come out in 2028, it was a very speculative bullet list of like, are we going to go ARM or stick with AMD's x86 stuff? But in that slide, they also used the term NPU, and that was the first time I had seen it, and that was in presumably an AMD context. And then here we are the next day, Intel talking about their NPU. So I gather that's going to be the generic industry term, probably going forward for this is our AI compute unit.
Well, they're not going to call them tensor cores.
Yeah, I think early on it was referred to as a VPU.
Yeah.
I know AM or Apple. I think Apple refers to it as an NPU. Like, I mean, essentially it's kind of the same thing. But yeah, I mean, the idea of having a whole separate compute, like a place to do computing, is wild. And especially here at Innovate, one of the big things that Intel people kept saying over and over again. I mean, the question is, okay, that's great, but what the hell can you do with it? Especially for the normal user right now, who's going to buy a laptop. Why do they care about a quote unquote AI PC? What is it going to do for them? And obviously there's demos. I mean, they showed it off, but at the same time, Intel's like, hey, listen, we want to get it out there. They had a number of like, I can't remember, like 10 million units, in the next year, because everything Intel based is going to have an NPU in it of some sort. So they want to get the hardware out there, and then let the market kind of decide what happens with it and how people are going to use it.
Well, so that's interesting for two reasons, right? One is that the most, it's interesting they put in the SoC versus in the compute chiplet, because if they put in the compute chiplet, it'll only go out on the high end stuff or in specific subsets. On the SoC, presumably that means it's going to be on literally everything they sell that is a Meteor Lake chip for the next year. So my guess is that the SoC is the gate on what the generational shifts. Like when that SoC shifts over, that's when we see them say, okay, this one's a 14th gen, this is a 15th gen, this is a whatever gen. That's a guess. I don't know for sure. They haven't said either, as far as I can tell.
What kind of demos did they show? Like what were the actual use cases for the hardware?
Yeah, so some of them were simple kind of things that we had seen before, like what is it, like video collaboration, enhancements, and this is actually something AMD showed off with as well. AMD would also like to point out they're the first ones with an AI accelerator on a chip. Came out earlier this year, so a couple of their laptop chips had a dedicated processor on there. I can't remember the exact details of it, but it's from their Xilinx acquisition. So AMD is working on this stuff, and technically they're first to it on the consumer side. But what they showed off is kind of the same thing that Intel was showing off, was that video collaboration stuff. Hey, it's a lot more power efficient if you can run background blur locally, on this processor. Same thing with like denoisers and things like that. AMD worked with Microsoft to build in this thing called Microsoft Studio Effects. So it's actually something that just shows up in your little pane when you click on it, and it's like, oh, Studio Effects, turn on black background blur and all that kind of stuff. Anyway, so they showed off that in the form of XSplit. So in the actual background blur and the face tracking was all happening on the NPU, and then they were feeding that feed into OBS, which was running on the GPU, and it's faster because of the 2 times performance on the ARC graphics chiplet. So there was that one. They had a Filmora, which is a video editing software. It was like real-time playback of effects that they were doing, and that was happening on the NPU. They showed Adobe Lightroom. They had a denoiser that just works quicker on the newer ARC GPU. That one was just on the GPU. They had GIMP running Stable Diffusion, a bunch of different plugins. And this is all enabled by OpenVino. But Stable Diffusion running inside GIMP, and they had the different options that you could have in the plugin. Be like, hey, do you want to pick the CPU, GPU, or NPU? The demo they were showing off was a mixture of all 3. And then one that was actually more near and dear to my heart was Audacity. They had a Stable Diffusion plugin, actually a couple plugins, but the one that I liked was a Stable Diffusion variant called Refusion, which, for me, like when I first saw it, I was like, wait, I thought Stable Diffusion was image based. This doesn't make sense. So what it's doing is like taking the audio spectrogram of it, which is what is it? It's like a visualization of the frequency spectrum.
Yeah, it's like a heat map for where the data is in the audio spectrum,
which is I mean, it's an image, right? So then you feed that image into Stable Diffusion, and it spits out a new image, then gets translated into audio. And what they were showing, well, one of the things they were showing for that was, hey, you know what? Take this song, like a Taylor Swift, kind of song, and make it EDM. So it would take a spectrogram of that song, run it through Stable Diffusion, which would spit out a different image of that, and it would play back. I mean, it wasn't great. It was fun. It was kind of fun to mess around with, but
it's weird, not useful, maybe.
Yeah. I mean, it could be. Like, I was thinking, I was like, man, we've had just a little inside baseball. We've had some like licensing problems with our the music on our podcast. Like we had a needle drop service that we didn't re-up with, and we went to a different service, and it was so we were like, well, crap. Okay, we got to change the podcast music. But now I was like, well, crap. I mean, if I can actually make podcast music, through Refusion, to be like, hey, you know what? Take kind of like that song and maybe spit something else. I mean, it's a rights thing, but yeah,
there's a whole can of worms, Adam.
Yeah.
So did they give you a sense of what the API or what the access to these Encores is like for developers? Is this something where there's a Windows or OS level API that developers are writing to, and then there's just a driver that lives between the NPU and the software and the OS? Or is this something where you have to build specifically? Is this like using CUDA cores for NVIDIA, where you have to build specifically for the core that you're working on?
I mean, they didn't show anybody who was building specifically for it, but that doesn't mean that I mean, that's probably going to happen. It wouldn't surprise me. But the thing that they were touting was OpenVino. And that's kind of like a translation, like an API, essentially. And it works in conjunction with things like the DirectML and things like that. So that's a little bit out of my pay grade. Like I kind of had to quickly learn how it was working at Innovation. But yeah, OpenVino was the thing they kept saying over and over and over again.
Is that just for Intel hardware? Do you know?
I actually don't know.
Okay, I looked it up on, it's open source. I pulled up the GitHub repo, and they mentioned Intel hardware enough that I assume it might be specific to Intel's stuff, but I'm not sure.
Yeah, I don't know. VNNI is another one that's in the compute chip. So there's different kinds of standards, but OpenVino was used it's all over the show floor. So I think that's where they're really hanging their hat.
This whole situation is interesting to me. Like the widespread use of the term NPU, like, you know, some people might be like, who cares what they call it? It's just jargon. But like, to me, it implies a process of standardization that kind of is very reminiscent of the 90s 3D accelerator wars, because like everybody's coming up with their own chip, right? Everybody now sees that there is a need for this type of compute. So they're all making their own thing. But they're all going to have their own custom API to go along with it, like 3dfx had Glide back in the day. And then we're going to go through some OpenGL, Direct3D kerfuffle of competing standards, and then eventually there will be just like the one API like DirectX that everybody uses for this stuff,
or Vulkan or OpenG. Like but it never. I
mean, it's never just one, but you know, it'll be settled. It'll be kind of settled to the extent that like, okay, this is what we use now. Like these are our options. We know what we're doing. There's no format war stuff going on anymore.
Well, in the Halleck talk, he was really pumping up like, hey, this is where Intel can play ball, you know, compared to AMD and to a certain degree NVIDIA, is that they were like, hey, here's the amount of developer support and money, you know, that we're able to get in there. And Gordon always talks about like, that's the key to success is DevRel, right? And why AMD has kind of lagged in a lot of ways, and why NVIDIA just kills it in a lot of ways as well. It's like, if you can put developers in there and spend the time and money to have them implement it, then you have a leg up. A lot of people say that's cheating. You just like, oh, you know,
I mean, look, it's a choice to invest money in. I used to feel like it was cheating 20 years ago. And now that I've been on the other end of the stick and actually been able to call people and get help with stuff, like it is an actual competitive advantage, I think.
And so in this case, Intel is saying, hey, like the amount of DevRel we have in here, the amount of support, they showed a list. I actually don't think it's in the slides that I had sent you guys, but they showed a list of companies that they're working with, that it was just like, hey, you know what, look at our list right now, and we haven't even launched compared to the other lists. And look, we got more names on this list.
I mean, the list with names on it is always kind of bullshit. But the thing to me that says, hey, we're committed to this is the thing that Apple did with like A13 or A14, whatever was the first one they shipped with neural engine support. They're saying, hey, we're putting it in all the phones, not just the good one. The fact that they're putting in the SoC chiplet instead of the graphics or compute chiplet says, hey, this is going to be on everything that's 14th gen, from the $100 processor that'll be out in 2.5 years. Like they're trying to get this to 1 billion users as fast as they can, and that to me is the mark. Because the interesting, like on the phone side, the place that this whole technology got interesting is when they stopped having to send voice stuff to the cloud to do the compute on Siri decodes or on Google Voice decodes, and when that happened, the time to response dropped from 300 or 400 milliseconds to like 75 or 100 milliseconds, and it feels much more instantaneous. It becomes much more usable, and that's why this is interesting coming in the CPUs. It feels overdue given what's happened on ARM in the last 5 years and how fast this stuff rolled out with ARM. Honestly,
well, yeah, and there's big benefits. I mean, Intel's first major benefit that they pointed out was, oh, hey, it's a lot cheaper to make the clients do it than have everything happen in the cloud. So, you know, which, you know, is not necessarily, I don't care, I guess, to a certain degree, but like to them, they're just like, hey, the more we can offload to the client side, the better, you know, and obviously if it's more efficient, then it's something that's going to be valuable. But also, I mean, there's privacy concerns too. There's a lot of people who really value their privacy and their data, and especially if they're feeding in sensitive material into these data sets, that they want to say, hey, you know what, I don't want this to be open to the public, then yeah, you can run it locally. I mean, another thing that's not as serious as that is face tagging, right? Like in Google Photos is like, hey, you know, like I'm going to tag all the faces and organize everything. But now there is, God, I can't remember. Gordon got a demo of a piece of software, and now the name is escaping me, where you can actually use local hardware to do all the face tagging. So it's just more private that way. So, I mean, there's benefits, but also at the same time, it's funny because on Thursday, which was 2 days after innovation started, Microsoft had their big event with updates to their Surface lines, but then talking about, what's coming with Windows and whatnot. And their big push was to put more things in the cloud because it's all subscription and service based. So like Intel 2 days prior was like, hey, we want to bring so much more stuff local. And then Microsoft was like, oh man, we want to do so much more on the cloud.
All the battle lines are being rewritten. It's weird that Intel sells CPUs to consumers and the cloud providers, and Microsoft is a big cloud service provider now. What a weird coincidence that. Should we talk about? So this is the other thing about Meteor Lake. We're almost done talking about the next year's processors, but it's what they're calling the Intel 4 process, which I think they previously called the 7 nanometer process. And this is a little in the weeds for us, but basically the story so far on Intel stuff is that over the last 50 years they've been better at process tech than pretty much everybody else there, and they've had a rough time the last few years for the first time in quite a while. And this seems to be them saying both this chip re-architecture and the 7 nanometer process seems to be them acknowledging the problems they've had and saying, here's what we're doing to make this work better. Do you think that's a fair read, or is that an oversimplification, Adam?
Yeah. Well, once again, like, yes, you could easily make fun of Intel's problems in the past, and being able to deliver stuff. And there's a lot of people out there who look forward thinking, and they're just like, oh man, this is Intel, they're talking a big game, and who knows if they're going to be able to deliver on this roadmap. But Pat was on stage and he's like, hey, listen, like the thing that I laid out last year is in place. We're rolling forward. And I'm sure in a different parallel universe, they wanted Meteor Lake Desktop to be alongside here at Innovation and talk about it. So I'm sure there's some sort of things that are going on that's not according to plan. But I mean, that's business. It doesn't surprise me, I guess.
What CPU designs are a 5 or 10 year development cycle at this point? Probably. I have no idea how long that stuff takes at this point.
Yeah, I mean, there's so much forward-facing stuff. Like I said, they kind of talked about in terms of like 4 years. Like that, usually that's kind of where they're talking about, and that now they're talking about the kind of newer generational technology stuff, like the glass core substrates and power via, like different power delivery methods, things like that. So I mean, they are talking about it, and they're looking forward and kind of being, like, hey, check this out, we're doing awesome stuff. Which, I mean, if it works and it comes out on time, cool. It is awesome stuff.
So can we dig a little bit of, I know you all, Gordon's rule always has been that anything that they're not shipping is bullshit until they start shipping it, kind of. Not that's unfair, but he's been skeptical of things that are on paper and not on silicon, I guess is what I would say.
I mean, there's a whole cottage industry of people who like to look to the future and leaks and roadmaps and try to, make assumptions and things like that.
Reading the PowerPoint tea leaves.
Yeah. On the PCWorld side, it's not just Gordon. Like I don't really care too much about like leaker culture and things like that. Brad Charkis, who's our managing editor, who kind of runs the day-to-day stuff on the website side, he's kind of in the same boat. We don't really get into a lot of rumors unless it's like, oh, okay, well, this rumor is like, oh, hey, this new GPU is probably coming out because one of the AIBs accidentally leaked it on their website. Like, that's like, okay, that's something you can hang your head on. But yeah, we typically like to just look at something when it comes out and say, oh, okay, well, what is it? How is it? Sure, maybe it could have been different in a different way, but it doesn't matter. This is what you're going to be buying off the shelf. This is how you're going to be using it, and just evaluate it like that.
But I mean, just to be clear, this isn't leaks. This is stuff that Intel stood up on a stage and said, "Hey, here's what we're doing over the next 4 or 5 years." In this case.
But I mean, it's usually it's paired with leaks of like, hey, you know what? Like I have some inside sources in their fabs, and they're running into problems here and there. So yeah, their roadmap says this, but production is not on.
Got it.
Anyway.
The big thing to me out of the long-term stuff that I read about out of this event is the UCIe stuff, which is their universal. Hold on, it's Universal Chiplet Interconnect Express, which is very conveniently close to PCIe, I guess, is the acronym.
Also, if amusing to see the word chiplet snuck its way in there. I thought something more professional or formal sounding.
And not tile. It could have been UTIE, but maybe UTI.
Totally.
Nobody wants a UTI, it turns out.
Exactly.
Ooh, thank you.
I'm so sleepy.
I've got the list. This is a full-on consortium. We love those around here.
I love a consortium.
It's everybody. It's, I think, Will, you were asking, or actually, sorry, you wrote in the show notes, is AMD on board with this? The members of this group are AMD, ARM, Google, Intel, Meta, Microsoft, Qualcomm, Samsung, TSMC, and ASE Group. So I think that's
NVIDIA is missing.
Oh yes, actually, that's the NVIDIA's well. Of course, they don't make CPUs exactly. Well, they
tried to, and then
they do make ARM
UK ones. Said, "Hey, you can't buy ARM. You can't make ARM CPU. You can't buy ARM."
Yes.
This was one that Intel rolled out and just built, and then just handed off to the group, right? Is that how this one worked? It seemed like I can't remember.
I personally don't have like too much knowledge into this stuff, but yeah, like it sounds like with a lot of different consortiums, usually something major is handed and said, "Hey, this is what we came up with. You know, what do we want to do with it?" So yeah, I think Intel was kind of leading the charge on that end.
This may be too in the weeds. I mean, maybe some hardware engineers could speak to this on our Discord or something. But I wonder what is the purpose of standardization in this space, because it's not like these companies are contributing different chiplets to the same design. Like everybody's chip exists unto itself, right? So like,
well, TSMC and Intel, I mean, obviously that's like they need to be working together. I mean, they're working together here in Meteor Lake.
But I assumed in that case that's Intel designing and providing specs to TSMC and just saying, "Hey, fab this." Not, like I wonder like how much interoperability does there actually need to be, or standardization in something where each product is kind of bespoke from each company.
Well, my guess is not an interoperability thing. Like I don't, but that's just like I think it's just more like, oh, hey, this is something that can benefit everybody, kind of thing.
Yeah,
but
okay, yeah, that may be the case. I may be missing some broad use case here.
It's if you look at what happened with ARM, they have a similar, like there's a protocol by which all ARM CPUs can talk to the other bits of the SoC, which is why Qualcomm and Apple and Motorola and 15 other companies can make modems for ARM phones, right? This gives them this fixes that SoC problem for x86 in a way that ARM it's just been table stakes for ARM since the beginning of ARM. And like, to me, that seems really interesting. It's interesting that ARM's a signatory on this too. So,
Qualcomm, like, there's definitely some news that Qualcomm is excited to get out there about getting like better laptop x86 laptop performance. Like, Gordon's definitely been like somebody to kind of put down Qualcomm chips on Windows for a while. I mean, it's a good story, but it's also one that they haven't executed on very well. So, I don't think they're getting out of it. It sounds like they really want to kind of push forward and be a big player there. So, I mean, yeah.
I should have asked this before, but does this mean that Meteor Lake's going to have AV1 support if you have an ARC GPU on the die? Probably,
yes.
Right?
Yes.
It does, yeah.
That's pretty exciting. Because there's not a lot. I mean, AMD does ARC, GPUs do ARC acceleration, I think, but NVIDIA doesn't right now. So for people who work in live video, that's thrilling.
40 series can encode AV1.
Yeah. There's AV1 on all of the newer GPUs now.
Yeah. Let's see. Should we dig into? Okay. So there's this Foveros thing, which is a little further off. That's Lunar Lake, which is for people keeping track at home. Meteor Lake is next year. Arrow Lake is the one after that. Lunar Lake is the one after that, and then Panther. I don't know why they like lakes so much, but Panther Lake is the fourth gen down the line from that's 5 generations from what's shipping today, basically. So Lunar Lake,
Panther Lake is far enough off that when I Google it, it still comes up with the actual Panther Lake first. The first result is Panther Lake Campground Road.
I mean, honestly, my favorite was Coffee Lake. I think you guys can dig that as a code name. It's just imagine a lake full of coffee. A lake full of panthers does not excite me.
No, that sounds bad.
Yeah.
I assume that there's a team of about 40 people at Intel that are just driving around the West looking for new lakes they can name stuff after with cool names.
Yeah, it's funny. That's another knockoff of Gordon is like there's the code names, right? Which we definitely should get into naming because that's a big topic. But the code name Meteor Lake is signifying something, but the more general consumer, they don't really care. They just look at like, is the number bigger? Which gen is it? Is it 12th gen, 13th gen, 14th gen? So like that's why usually on the package they don't really talk about lakes kind of thing. This is more of a internal kind of discussion.
Well, and I kind of wonder, like, typically when they've made a big change to the architecture like this, they often drop the old branding and go to new branding. Like the move from Pentium to Core happened when they went to multiple. Like, did they announce branding for these for the Meteor Lake stuff, or is it they said it's gonna be 14 series?
No, all they've given us so far, which there was actually a lot of talk around the naming stuff, but all they've given us so far is now it's Intel Core Ultra processors.
Yeah, so I think
they're dropping the i9 and the i5 and the i3.
Yeah. Some of that came out in like June, I think they announced, like they were dropping the i and everything, but like this sounds so they're not putting generational markers on the product naming anymore. Is that correct?
So there will be. We just don't know exactly how it's going to be. There was talk of series nomenclature, like the Xbox, like, hey, here's Core Ultra Series 1, here's Core Ultra Series 2. But in terms of numbering, I'm sure they're going to have some sort of number, or they will have some sort of number, and supposedly it'll just start with a 1. So instead of a like a 13900K kind of thing, like the 13 is in reference to the generation. Now it's just dropping back down to 1. So this will be first gen.
I guess you see that with everybody, then. Right? Like there's since in a base 10 world, there's only so much you can do. Like NVIDIA also, right, has to start over every decade or so.
Right. Yeah. I mean, Samsung phones, right? It was 1 through 10, and then now it's just the 10, 20, 30, 40 kind of thing. So, I mean, naming is hard and naming sucks. I think that's the biggest question coming out of here is like, okay, with so many different options and the fact that the generations of each tile can change, or I'm sorry, the process technology of each tile can change and the configurations can change. How the hell are you going to market this to people? I mean, because Core Ultra is only one part of the naming. Like you need some sort of signifier of what's going to be in it. What kind of generational technology, because I mean at the end of the day people are going to look at the number and be like, okay, well this number is bigger and better. So AMD has kind of done this a little bit on the laptop side. They at their event last year they gave us literally a decoder wheel. I wish I had it on me because it's hilarious. Incredible. But it was like a decoder wheel where it's like, hey, the first digit means this, the first digit meant a year, the second digit meant the architecture, so like Zen 3 or Zen 2, so yeah.
That might be the most self-aware marketing tchotchke I have ever heard of.
But also like this all comes out. This is like the last vestige, the last bad vestige from computer nerds starting out as car nerds, where everybody's like, man, Mercedes really does this right. That the 3 Series is the cheap one and the 6 Series is the expensive one, and like then whether it's the 2 or the 30 or the 35 or what, like. Oh God, it's too complicated for that. Just make a sane naming scheme, man.
Yeah, I mean the least complicated thing I think was to drop the I. Like yeah, it signifies something for historical purposes, but also at the same time, do you really need the I there? It's not like there was a different letter before a number. I mean, so.
Yeah, because like and like the i5, i3, i7, i9. Used to, like, when they first rolled that out, that meant something specific in terms of like what was on the, like the i5s had graphics processors and the i7s were unlocked, and like there were meanings to those things, and then those gradually eroded away until it just meant that the 9 was the expensive one and the 3 was the cheap one, and the 5 and the 7 were in between.
Well, so, and now it's like, what is it? The K's are unlocked. The F's have no GPU. Is that right?
Yep.
Or is it it's right? But they're also
S is like a spec bump.
But wait, can the K's get F'd, or yes. Do the K's have to have F's?
There's KFs. Yeah.
Okay.
Right. Yes. So I mean, when you're just layering hierarchical naming nonsense on top of your thing, maybe it is time to start over.
Yeah. But that's the thing. Like they're going to start over, and it's going to be complicated as hell. I don't think nobody there made me feel like oh yeah, we've got it under control. It's going to make crystal clear sense. So
Look,
I think it's just going to be different.
Well, I mean, it seems like with that many variables on the package now, the onus is on them to keep the roadmap like focused and sensible and understandable, right? Like
the way they were talking about it, or at least Michelle Johnson Holthouse, I mean, that's one of her main jobs is to figure this out. The way she was talking about it was like, hey, like you just buy it for your use case. So it sounds like maybe they'll be aligned for gaming. Maybe they'll be aligned for content creation. Maybe there's a line for low power. I don't know. Once again, they haven't like actually given anything other than Core Ultra, but maybe there's not an Ultra. Maybe there's like Core is maybe a signifier of something. Maybe Ultra is a signifier of something. We just don't know exactly what that means.
Yeah, it could be that like the Core means the SoC, and the Ultra means the Core 1 means the first gen SoC, and then the Ultra means it has a GPU, and then Extreme means it has the gamer CPU, the gamer compute tile, and then plus means it has double IO for faster lanes. So what you have is a 23-digit long character serial number, and if you look at the 4-character blocks, then the hex will tell you exactly which one is inside. It's simple, and even a baby could do this.
Can I? Okay, I just want to make sure I got the
like monitors.
Core 1 Ultra Extreme Plus Plus. Is that what we've got?
That's my bet. That's what I'm thinking. Probably.
I like it. You know what? Just hire us until
and it's worth noting 1 plus is spelled out, and the other one is the plus sign.
Aha. Okay.
So
I'm just amending this podcast title. All right.
I assume this is the podcast title now. Yeah, you're welcome. Speaking of stupid names, can we talk about Foveros for a minute? Because this is another thing on their long-term roadmap that looked neat. And I watched a 2-minute video and I was like, oh, that makes sense. And then as soon as the video stopped, I was like, I don't have any idea what I just saw, but I think that it means that the chips are stacked on top of each other now.
Yeah. I mean, the ability. Okay, so there's a lot of people love to keep talking about, oh, Moore's Law isn't dead. And then some executive will come on and either be like, yeah, Moore's Law is dead or it's not. So, I mean, they're just trying to figure out different ways to package this stuff, shrink the actual processes and have it be stable. And yeah, there's a lot going on. Foveros is one of those. Power Via, which is a power delivery method, is another thing. Like I said, the glass substrate is something they just kind of started talking about. So like there's different ways to kind of package this stuff up that is very forward thinking. Foveros as a name, I mean, whatever. Like
I think
Panther
about
Lake, I think is
yeah.
Panther Lake seems like a crappier name to me, but it's whatever. It's a different thing.
Foveros seems like it should be a visual learning AI company or something. Anyway, yeah.
Right.
So we don't need to worry about
too many.
That's for the future, right?
It's for the future. Yeah, it's the way things are going to be put together. Really, like they need to figure out. And then I mean, same thing with the EVU or whatever the ultraviolet
extreme
light
UV.
Yeah, extreme UV. I'm sorry. The idea of, hey, instead of blasting ultraviolet 4 times, now we only have to blast it once. There's a different, and that's going to have implications to cut down on like things that go wrong and things like that. So it's very complicated. Supposedly that actually has to happen in a vacuum too. Like, and there's only one company that's making these kind of things. So like they got to see that in Malaysia. So I don't really have a ton of knowledge into that, but that seems like, oh, that's crazy shit.
Anytime they're talking about like, hey, we have to come up with a new way to do this process like this. We're inventing new technology for this process to work. That's when you start thinking, oh, this is one that's either going to be hard to get at launch or they're going to maybe push this. I guess by the time they start talking about it, they're pretty committed to it and they're not going to change. But other than that, it's often like wild stuff that means it's going to be hard to get these CPUs when they land. So.
I mean, I started to making like a sneering comment about the angstrom era, but now that I'm looking at their 18A process, it's like, I mean, we're approaching the sub-nanometer era, like legitimately, right? So like this technology is probably going to have to get insane to accomplish that, right? Like the Intel 18A process is 1.8 nanometers apparently.
I mean, that is the crazy stuff. Like for me, like somebody who doesn't have a background in electric, engineering, anything like, all this stuff is like way over my head. But for me, like the fact from the outside, seeing that so many people are trying to figure out different ways to like continue to push technology forward, like it just seems exciting. If anything, like to, even if I don't fully understand it, I can look at it and be like, oh my God, like people seem to really be trying to figure this shit out.
Well, I mean, it's worth remembering that Intel built a multi-billion-dollar company on being real good at process technology for 50 years, right? Mm-hmm. And like that's why they always invested a lot in process technology. TSMC and other companies obviously do too, but like the company that figures this stuff out first wins in an enormous way, because at the end of the day, the performance is what matters to the vast majority of the market. So. It's really fun. Thanks for coming by and talking about this stuff, Adam. I've definitely learned a lot.
No, thank you. Once again, if anything, I'm just excited. This just feels like we're stepping into a new age of computing. And even though we can't really see, we're kind of looking off in the distance and being like, okay, what does this mean? How is this going to change things? Like, I really think like things are going to look different. Like computing 5 years from now is going to look way different than now. It's exciting.
It feels like there have been multiple parallel paradigm shifts taking place, both at the micro, like in CPUs. You've had big and little cores, and also the modular chiplet stuff happening kind of simultaneously. And then like on the like bigger picture, like you've got the machine learning acceleration coming in. Like there's still like hybridizing between local and cloud compute going on. Like I've really wonder what the hell computing looks like 10 or 15 years from now in terms of like use cases that nobody has even thought of yet.
Yeah. And it makes our job, or I should say Gordon and I's job, even harder to be like, okay, well, how do you even benchmark this stuff? Right. I mean, like one of the things that Gordon and I have been talking about for a while is like, I mean, the amount of people who even care about Cinebench performance to like pound every core is like very minuscule, right? Like, I mean, most of the people using computers, it just works, and they don't need a ton of performance kind of stuff. So like, okay, how do we figure this out? How do we benchmark it? I mean, we can't even figure out reliable multi-application benchmarks. We're still stuck, or for better or worse, we're still stuck in like, hey, you literally configure it so you're just benchmarking one application at a time and in showing the performance of that one application. That's not how people use computers anymore. And now we're going to be even further behind, because now there's different, a new processing unit in there that's happening at the same time. And like, there's no standard benchmark around that either. Like there's no Cinebench for NPU performance really.
Well, it's interesting, because as I've been doing more even like game development stuff, which is pretty light. I mean, it's as light as anything can be that you have an Unreal editor open, I guess. But like I'll have Photoshop and Audition and Wise and Unreal Ed all open at the same time. And like none of those are light applications. I mean, Photoshop is the lightest of those at this point, probably, which is kind of remarkable. And like it's to the point now that when I run that stuff on my old machine on the i9-9900K, which is not an insubstantial computer from like 4 or 5 years ago, it feels slow. Like there's a noticeable difference. So there is benefit to upgrading to newer machines. It's just, I don't envy you all having to figure out how to benchmark stuff with a 32 cores. It seems like a nightmare. Well,
I mean, and it used to be, I mean, for me on the video side, like I would queue up a video to encode, and then I'd be like, nope, don't touch it. Just let it do its thing. I'm going to go off, do something else. Now I'm like, oh yeah, I can make a thumbnail while I'm encoding, while I'm also, listening to a podcast and playing a YouTube video. Like people can do so many multitasking stuff that like, I still feel like benchmarking is still kind of in like a different era, like of when, everything could hit your system at once and you didn't really want to mess with it. Now it's like, yeah.
Well, and we always at Maximum PC, we always tended to prefer real world benchmarks, which is why like Cinebench was a useful thing, because it would actually measured, video edit and encode, nonlinear video edit and encode and like color grading and all those kinds of things. Whereas like phone benchmarking has a similar series of problems, right? It's mostly about experience. It's all single application at a time, but you're comparing multiple different architectures and multiple different OSs across all sorts of different. There's too many variables to do apples to apples benchmarking, so you end up in a situation
that doesn't stop people from trying though. Geekbench. Well, I was going to say Geekbench is the benchmark for Twitter.
I mean, that's how you end up with stuff like Geekbench. That is like it spits out a number, and sometimes one number is bigger than the other. What does it actually mean? I have no idea, man. It's like what is a 3D Mark? Well, a 3D Mark 13 is this much faster than a 3D Mark 14. I know that, but beyond like it's a hard situation, and it's not going to get easier, unfortunately, especially as like how do you compare this to Apple's M Silicon on their notebooks, and how do you benchmark an Intel laptop versus an AMD laptop versus a Mac when you can't run the same OS on them? And well, good luck, Adam, is I guess what I'm saying. You guys are doing great over there.
Yeah, well, thanks. And I mean, you have a lot of people who want to get really deep into the benchmarks and figure out like, okay, what's my best bang for my buck, or so because of these costs, the costs of all these parts are so high, people are trying to get more out of them, and they want to feel like they're getting the best that they can, but also at the same time, like people who are just building i3 systems are like, oh, well, this is great. I'm having no problem.
Well, I mean, the one thing that is true and has remained true for the last decade at this point is that generally, if you buy a newer piece of hardware at the same price point as your old piece of hardware, the new one's going to be faster and better pretty consistently across the board. Like if you have a mid-range i5 from 5 years ago and you replace it with a mid-range i5 from right now, you're going to have a much better machine than you had before for probably around the same money, maybe less if you count and if inflation matters to you. So,
all right.
I don't know.
Fun times.
Yeah. Adam, where can people find you?
PCWorld.com, YouTube.com/PCWorld. We have a weekly podcast called The Full Nerd. I am stepping in for hosting duties. Brad was on recently. Will we need to get you on again?
I'll come by. I'll come by anytime. I love chatting with you and Brad.
Yeah. We over on the YouTube channel. I mean, I'd like to have fun. Honestly, we do a lot of dumb experimentation stuff. We do some serious benchmarking as well. I have a couple live builds coming up. I like just hanging out and building stuff live. I'll say when I built my first system, which I mean, this will be an indicator of how new I am compared to you guys, but I built my first PC in 2011, probably. And when I was building it, I just sat down and watched, there was a tested video. There was actually a giant bomb video as well, where you just, recorded the whole thing, just going through and like, that's what I like doing is like, hey, I just like hanging out and doing live builds, because some people just use it to hang out and have fun. But then some people actually do use it as a way to build in real time and kind of, even though it's not like a tutorial, anything like that, it's still fun to just hang out and kind of see.
Well, the thing that I like about your live builds, and just to be clear, Brad and I both have built computers on your stream, on your YouTube channel at this point.
It's fun time. Got to do it again.
Well, yeah. I mean, God, not for a while, I hope. But you like, it's good to show the mistakes, right? Like YouTube gets really angry when you show mistakes, but also everybody makes mistakes, even people who are really good at this and do it all the time. And when you don't show the mistakes on YouTube, then it makes it harder for new people to get into this, because they think, hey, I've messed this up. I just spent $1,000 on this thing and now it's not working. I'm doomed. But literally, I mean, okay, so it doesn't happen all that, but most people, when they power up the machine the first time, it's not going to boot, right? There's going to be you didn't plug something in right. You don't have your memory pushed in all the way, whatever it is. It's not going to boot. It's not a big deal. You turn the power off, you take stuff in and out, you plug it back in, you make sure all your cables are in, the buttons hooked up and all that. And then the second time, usually you get a little more love. It's not the end of the world if it doesn't work. And just knowing that even people who do it all the time make mistakes is comforting and makes it more approachable, more accessible for everyone, I think. So I love what you all do over there.
I make mistakes all the time. We made mistakes with your build, Will.
Yeah.
When we were like, oh crap, the radiator's not going to fit.
But it did.
We made it fit. We
got it in. Yeah, we got it in there. But yeah, so it's a you guys do really good stuff over there, and people should check it out.
Thank you.
And we really appreciate you taking the time to come by, and hope we'll have to have you on again sometime soon, Adam. This has been great.
It's an honor. Yeah, no, I love what you guys do, and listen to almost every podcast that comes out on the feed. So keep doing what you're doing.
Thank you so much, Adam. Adam, thank you so much for coming on the show. It's wonderful to have you. And again, you can find him at PCWorld.com or YouTube.com/PCWorld.
Yes, I'll put some links to some of their innovation videos in the show notes for this episode.
Yeah, they had a lot of good stuff. It's funny, I've been dipping into PC World videos recently too, looking at interviews with some of their memory vendors from Computex earlier this year for reasons that we might talk about in the not too distant future. Keen-eared listeners, I guess, might realize that this was the last Sunday of the month, which we didn't realize until about 5 minutes ago. So we'll do Q&A next week. Fear not, you can send your questions in to techpod@content.town or post them in the questions seeking answers channel in the Discord.
We discovered next month, or maybe this month? No, next month.
Next month.
Sorry.
Next month.
I forgot what day it was. Next month is a 5 Sunday month, meaning it will now be a 2 email month.
Double Q's means twice the A's. But as always, we reach the end of the show where we thank our patrons for supporting the podcast. Without the patrons, this podcast wouldn't be possible. So, as always, we want to start by thanking everyone. Thanks, patrons. We appreciate you.
Thank you, patrons.
Special thank you goes out to our executive producer tier patrons, including Andrew Slosky, Bunny Fiend, Paddle Creek Games, makers of Fractured Veil, David Allen, James Kamek, Joel Krauska, Jordan Lippett, Just Wedge, Nick Johnston, Twinkle Twinkie, and Pantheon, makers of the HS3 high-speed 3D printer. Thank you all so much.
Yes, thank you.
And since it is the last episode of the month, we also thank our associate producer tier patrons, including Arthur Geese, Alejandro Navarro, Andre M. Burke, Ben Tallman, Dave Julian, Eric Frey, Eric Klein. Still only 3 Erics. I'm hoping for a 4th Eric one day, but we'll get there. Felix Kramer, Graham Banks, Jad Rita, Jason Rooney the Ref, Matt Walker, parentheses, Walkman 8080, close parentheses, Nathan Phelps, Sanchit Kumar, Steve Lynn, Thomas Shea, and Tom Hilton. Thank you all so much.
Thank you, everyone. We got to increase our Eric rate.
Yeah, we look, if we aren't at least, I want at least 10% Erics next month in the associate producer tier. That's Erics, we need you.
Got to boost the Eric stepping around here.
But we do appreciate everybody who supports the show. If you want to find out how to do that, you can go to patreon.com/techpod. And for $5 a month, you get access to the fabulous patron episode where we're going to reminisce on 200 and change episodes of the pod.
That's right.
This month, as well as I assume we said we were going to talk about Brad's TV. I think we might blow that out to a whole episode or part of a whole episode at this point.
Maybe not a whole episode, but we'll definitely talk about it in a public episode and not put it behind the patron wall, because we have definitely had some requests from people to talk about whether I like it or not.
Brad likes TV. We'll find out soon.
Can't wait to tell you about the boot loop that it got stuck in yesterday.
Oh, I love a boot loop. That sounds fun. Did you get a Canadian TV?
No, it's a Google TV.
Oh, ooh.
Actually, my TV runs Android.
Wow, I don't know about that. But we will be back next week with another episode of the Tech Pod. Thanks everybody for listening. And thanks Adam for coming by. We really appreciate it. And we will see you all next time on Brad and Will Made a Tech Pod.